The question before us says discuss circular functions. Alright. Remember in our last class I taught us how to divide circles in order to get angle and radius. Taught us how to divide circle into 4 equal parts, or you see 8 equal parts, or you see 6 equal parts, or you see 12 equal parts. I mean dividing up and down. So if I know this, for circular functions, we'll try to combine this. Looking at this, first of all, we'll say, let's say this is a circle. If I divide this circle this way, up and down, the vertical axis and the horizontal axis, I can easily see that whatever I have this side is for x, or you see I have this side to be 0. Okay. Then this side to be 90 degrees, this side to be 180 degrees, and this side to be 270 degrees, this side to be 360 degrees. Remember, I still moved on in our last class to say that this is also 360 plus 90, which is 450 degrees. Then 450 plus 90, 540 degrees. Then that is to show you it doesn't stop at 360. 360 is just one revolution. So for second revolution, you're having it if it's more than. So this is going to be should be 630. Forgotten what we did, but it should be 630 degrees. Then 720 degrees. So if I know this, I now need to remember that for every right angle, if we are considering 90 degrees, you remember that I said that the adjacent is 0. Why this side is 1, this side is 1? Because you're on the outside. That is why we say an hypotenuse here is this way, opposite here is this way, 1 over 1 is 1. That's why sine of 90 is 1. Why cos of 90, adjacent 0 over 1 is 0. So cos 90 is 0. So if I know this, I will now come back here and remember that I can have two cases where I'm dividing this into 4 equal parts or 6 equal parts. Notice that 4 over 6 is the same thing as 3 over. Is the same thing as saying 2 over 3. So another way to say 120 is 2 over 3. So if I know this, if I can choose to combine this. That is why you now see some books where you are having things like maybe something of this nature. You are seeing like, I'm coming, let me show you what they normally do. And this is what makes some of you want to run mad. They will do this, then they will come here and do 1 pi over 4. Then come here and do 2 pi over 4. Then come here and do 3 pi over 4. Then I do 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. When they finish doing this, then they'll come here and do. So it's more like they are combining these two things when they are talking about circular function. And I told you it's all about dividing into 6 equal parts. Go and watch my video on units of angle measurements. So outside here, this angle, when I divide 360 into 12, or I say divide up 180 into 6, I'll have 1 pi over 6. Then, if this is 30, this side should be like 60 for me. So I'll have 2 pi over 6. Then I have 99 to be 3 pi over 6. So I now have another, which is 120 to be 4 pi over 6. Then I now have the division. I might not be dividing it well as I should, but understand, use your measurements and divide well, find the angle. It's 5 pi over 6. Then you now come and see here to be 6 pi over 6. You see 210 to be 7 pi over 6. You see something this way to be 8 pi over 6. Then you have 9 pi over 6. Then you have this way to be 10 pi over 6. You have 11 pi over 6. Then you have 12 pi over 6. So what they've done, what they normally do when they put all these things is simply combining, dividing this into 4 equal parts and dividing into 6 equal parts. And sometimes you even see all these ones that still can be divided, they break it down. For example, when you have 8 pi over 6, 8 pi over 6 is the same thing as saying 2 go here, 4, 2 go here, 3. This can be the same thing as saying 4 pi over 3. Then 9 over 6, 3 go here, 3, 3 go here, 2. This can be the same thing as saying 3 pi over 2. Here, 2 go here, 5, 2 go here, 2. This can be the same thing as saying 5 pi over 2. So depending on how you see this thing in some books, here that you have 120, where is that 120? 3 pi over 4, is it? So yeah, this is 5 pi over 6. For 120 is 4 pi over 6. Should be 4 pi over 6. What did I do outside here, sir? This should be 4 pi over 6. Sorry, 4 pi over 6, not over 4. 4 pi over 6. This can be the same thing as saying 2 over 3 pi. So whichever one. So all these things now, you need to go and watch my video on angle measurement, units of angle measurement, so you understand this. So this is what they normally do. So when they finish this, I'm trying to show you how they get all those circles that they normally do that confuses you. Then when they finish this, they will come and start doing minus sign. They come and say to you that on the x part, you have like positive. And positive times 1 is positive. Then 0 times positive is 0. So you now have plus 1 plus 0. Then here you have again. Or you say, yes. Then you come and have here. Sorry, you can say 0, 0, 0. You can say 0, 0 here. Let's use it this way. Then you have, yes, here. There is no x. So you can use 0, 0. You use plus 1, then 0. That's for x. Then here you have y is 1 plus 1. Then you have no x here, 0. So here x is negative. So you have minus 1. Then you have no y here, so 0. Then down here you have minus, sorry, you have 0x. Then you have minus 1 for y, or you see minus y, 0x. Then here plus x, no 0y. So here you have, here up here is y, you have 0x, you see 0x, then plus y. So I'm trying to show you how they do all those things. Minus x, 0y. So all those things you normally see online, or maybe your textbook is looking confusing. This is how they go about it. Then when they finish this, they will start getting the trig ratios. That is using the 6 major trig functions, which is sine, cos. And notice that all sine, every sine, the highest is 90, others fall below. So it's going to be always 1 as the highest. Cos, tan, cosec, sec, and then, okay, let me do it here. Cosec, sec, and cotan, cot. So if that is the case, you know that this is opposite over hypotenuse. This one is adjacent over hypotenuse. This one is opposite over adjacent. Or you say numerator sine over numerator cos. While this one cosecant is the inverse of sine. So this is the same thing as saying 1 over sine. Or you say hypotenuse over opposite. This is the same as 1 over cos, or you see hypotenuse over adjacent. Then this one is the same as 1 over tan, or you see adjacent over opposite, or you see cos over sine. Remember that this is also the same thing as saying sine over cos, or you say x over, sorry, y over x, or you see slope. So this is also the same thing as saying 1 over slope. So at this junction now, when they now ask you about the circular function, what this thing means is using this principle, this same approach, go to these things we've drafted here. If you are here and you've not watched the video on units of angle measurements and you are hoping to understand this, you must be a sorcerer, or maybe you did your secondary school very well. So let's say I'll come to now 30 degrees. I know that this is angle 30. If looking at everything I've combined here will confuse you, remember this is the first chart. So this is 30 degrees. If I come to 30 degrees, which is 1 pi over 6, and come to 30 degrees now, I'll say that this is the same thing as saying sine 30. If you remember, notice, if I draft this thing down, this is the angle, acute angle. All those angles will always be acute. Notice that this side, 150 is equals to 30 degrees. This side, this is 30, but 150, that's same. Then this side, this is 30, this is 30. So this is the angle, this is the angle. All the angles will always be less than 90. So if I know this, I want to do sine 30 now. I will say, if this is here, if you remember that our approach, here we said we'll call if we have this, something like this. Remember where we say if we have this, not our equilateral triangle, that we'll call this 2, call this 2, call this 1, call this 1, so that everything here is 2. So carry like some part of this, which is something of this nature. So come, you see that this place is 2, and this place, the adjacent is 1. So because the other part is not here, it's to this end. So if I call this 1, you see that opposite here, opposite of this is something I don't know. Okay, so if I do opposite, so that is sine 30 now, opposite over hypotenuse. What am I doing? So opposite over hypotenuse, sine 30 should be 1 over 2. So let's check and see that we are doing things well. So if we do this well, that time we did that thing, I'll put this way. Let me be sure. So this should be h square equals to 2 square plus sorry 2 square equals to, okay, so see the mistake we are making. So the angle here is actually 60 degrees. The angle here is actually 60 degrees, while the angle on this is the 30 degrees that we have. 30 degrees. So if I know this, it simply means that if I'm applying it now, I'm going to be having this angle to be, so I'm going to be having this one, looking at this, the opposite of this is 1 over, the hypotenuse is 2, so this is going to be 1 over 2. Yes, because if you choose to call this angle 30, if you choose to call this angle 30 degrees, it simply means that this is the opposite. The thing I should put here should not be 1. Yes, so that's why I'm supposed to put 1 here in that case. So that's why I'm making it 30 this way. So, and I know that anytime sine is half, sine 30 is half, cos will be √3 over 2. Then tan 30, since this is 2 and this is 2, tan 30 will simply be the same thing as saying numerator sine, numerator cos, which is 1 over √3. and root 3 cannot be a denominator, so it's times root 3 over root 3. So this will be the same thing as saying root 3 over root 9, which is equals to root 3 over 3. So now that I've gotten this, for the cosecant, since this is 1 over 2, if you reverse it, that is 1 divided by 1 over 2, it becomes 1 times 2 over 1, which is the same thing as saying 2. So the cosecant is the inverse, is 2. Or you say just flip it. Why for the secant, which is inverse of cos, since cos 30 is root 3 over 2, just reverse it so that you have 2 root 3. And root 3 cannot be under, so you have times root 3 over root 3, which is the same thing as saying 2 root 3 over 3. Then cot, which here is root 3 over 3. So this is going to be root 3 over 3, then divided by 1, which is the same thing as saying 3 over root 3. And root 3 cannot be under, so you do times root 3 over root 3, which is the same thing as saying 3 root 3 all over 3. So I've already made video on how to derive all the angles. So but what I'm trying to do is to create that circle that you normally see, that normally confuse sometimes. So you will come and see beside where you have 30 now, like somewhere here, you come and see something like, for the x, you know that we consider x to be cos. I've proved it before. I will consider y to be sine theta. And I told you that if you have something like a, b, the first one is x and the second one is y. So you will now come and see maybe around this place that pi over 6, which means 30 degrees. Come and see something like root 3 over 2, 1 over 2. What they are talking about is sine cos 30 to 3, then sine 30 equals to this. And remember that in the first quadrant, A, S, T, C, all of them are positive. Only sine is positive, only tan positive, only cos positive in the fourth quadrant, first, second, third, fourth. So we'll still do this in our next class. So you now come and see, most cases you just do x and y, don't put the tan. Then if you come to this part of 60 now, you know that when you have cos 30, you normally follow this rule. Cos theta is equals to 90, is equals to sine 90 minus theta. And sine theta is equals to cos 90 minus theta. So if I have, for example, cos 30, it's the same thing as saying sine 90 minus 30 degrees, which is the same thing as saying sine 60 degrees. So sine 60 is equals to cos 30. So if I have, for example, cos 30, it's the same thing as saying cos 90 minus 30, which is equals to 60 degrees. So sine 30 is equals to cos 60 degrees. So it's more like inverse. So here where I have 30 and I have root 3 for the cos, and I have 1 over 2, root 3 over 2 for the cos, and this, just flip it, reverse it, so that x here will be 1 over 2, and then then root 3 over 2. Just flip it. So cos 60 is half. Cos 60 is half. 1 sine 60 is root 3 over 2. And this thing means y-axis, x-axis, x-axis, y-axis. So this is how you normally see all those things running around. Now, as he moves this way, you come and see maybe around here. We know that 150 is the equivalent of 30 degrees in the second quadrant. In the second quadrant, you have 150. First quadrant, you have 30. So you see that in the first and second quadrant, sine is always positive. I'll still prove it to you. Remember, A for all, then sine. So here you come and see like something like this. You come and see here, root 3 over 2. Then you now see 1 over 2. This thing means x-axis, y-axis, and this is for sine. This one will be positive, but you come and see minus on this one because cos is negative here. Then for the 60, the part of 60 now, come and see the same thing. Just rewrite it. Half, then 3/2. So you see that for sine 60, which is in the sine 60, which is the same thing as 120 degrees, it is going to be √3/2, still positive. But cos 60, which is the same thing as cos 120 in the second quadrant, will be negative, because cos is negative in the second quadrant. So this is why you normally see all those things this way. So you need to go through my videos. I'm rushing this video, but if you go through all my videos, you'll be able to understand all these things, because it's one step at a time. This one leads up to this one. So in our next class, we'll be talking about, discuss in detail, trigonometric ratios of general angle. This is where I will now take time to show you why and how I normally see them together. I'll be doing this number 6 and number 10. I'm doing number 6 and number 10 together. Trigonometric quadrant of the coordinate axis, give the signs and trigonometric functions respectively. So I'll be doing the two together so that I can be able to extensively point out how and why I say that. To also prove why I say that all is positive in the first quadrant, only sine is positive in the second quadrant, and only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant. So I'll be proving this in the next class, then detailing you everything you need to know about this. Then the parts that might be confusing is this part where I found angle here and I say it's 30 degrees. Even if I choose to call this angle 30 degrees, let's say I call this angle 30 degrees, what it simply means is that when I'm doing this opposite, I should call here 1. And if I'm calling here 1, I will now call the adjacent √3, because sine 30 is 1/2. So go to my former video and check it out. So go and check it out. But if it will confuse you, you always take this part to it. Thank you. Subscribe.